Hello. In this session, we're going to discuss changes in health data coding systems and the functions of comparability ratio and jump models in joint-point regression. Data items in the health-related time series of morbidity, mortality, etc. are often recorded or classified based on certain types of coding systems. Examples of coding systems used in health data are ICD, ICF, and ICHI. ICD being International Classification of Diseases, which was designed for the systematic recording, analysis, interpretation, and comparison of mortality and morbidity data collected in different countries or regions and at different times. The ICD-11 is the latest revision of the ICD coding systems. The International Classification of Functioning, Disability and Health was a framework for describing and organizing information on functioning and disability, which was officially annually updated until 2018. And International Classification of Health Interventions was a common tool for reporting and analyzing health interventions for clinical and statistical purposes. However, sometimes the coding of health conditions changes over time. For instance, the ICD-10, which was used before ICD-11, was updated annually from 1996 all the way to 2019, and in these two slides you can see all the updates that were officially released for ICD-10. Another example would be cancer staging algorithms that change across time periods. In these situations, the data of the previous coding and the data of the new coding may not be comparable to each other. The change in coding may result in a jump. This jump could be either positive or negative, meaning that the number of individuals with the condition of interest could show either an increase or a decrease based on the new code. When there is a discontinuity or jump that occurs in the data, the joint-point model could potentially result in a misleading interpretation of trend changes, because the jump could be the result of a one-time external circumstance which may not be interpreted as a changing point in the data. There are several methods to deal with the problem of the change in the coding system, one being breaking down the dataset and performing a separate analysis for each period. An example of that would be Lee et al. 2024, or we could use comparability ratio or the jump model in joint-point regression. But what are jump model and comparability ratio? These functions are used when there is a systematic scale change which causes a jump in the rates but is assumed not to affect the underlying trend. In these situations, the jump is due to a coding change, and these techniques are used to provide a direct estimation of the trend data. In some cases, the size of the jump either is known or it could be estimated. In joint-point regression analysis, the comparability ratio converts the data before the jump by the size of the jump. For comparability ratios, we would need external studies, since comparability ratio is estimated in these studies performing a double coding, which means that one population is coded once with the new code and once with the old coding system. In joint-point regression trend analysis software, we can use only a single comparability ratio. Comparability ratio is calculated based on this formula, which is dividing number of cases classified by the new coding system by the number of cases classified by the old coding system. If the comparability ratio for a cause is more than 1, that means more events are being classified to this cause under the new coding system compared to the previous one. If the comparability ratio is less than 1, then fewer events are being classified to discuss under the new coding system. And if comparability ratio equals 1, that means that the data were not affected by the change in the coding system. For using comparability ratio in joint-point regression, we need the location of the last observation of the old coding, the location of the first observation of the new coding, the value of the comparability ratio, and its variance. If the location of the jump is known but the comparability ratio is unknown, we can use the jump model function instead of the comparability ratio. In joint-point regression, we can denote the jump in the formula where lambda is the size of the jump. Advantages of using jump model to comparability ratio are that jump model uses model-based comparability ratio, which can be directly estimated from the data. The comparability ratio model may not be suitable for practical use in some cases where the statistical variability of the comparability ratio is high or the accuracy or applicability of the estimate is questionable. For instance, sampling error or small numbers in the double coding studies may result in unstable comparability ratios that we should not use, and comparability ratio of a certain population may not be generalizable to the study population. However, jump model is sensitive to the data and the location of the join points. For instance, if the location of the jump is close to a join point, the estimate of jump size might be confounded with the slopes before and after the join point itself. Where the jump size is not statistically significant, comparability ratio model may be preferred. Also, the underlying data variability may also make the estimation of a small or modest jump size impossible. It is suggested to apply both the comparability ratio and jump models to datasets to consider the best fit for particular scenarios. In order to use comparability ratio and jump model functions in joint-point regression trend analysis software, after loading the data, we will come to advanced analysis tools and click on jump model comparability ratio model. Here we can choose which method we want to use. For instance, if we want to use comparability ratio, we will click on comparability ratio, and certain options will be available after we click on this option. Here in last observation of the old coding, we will choose the last time the old coding was used, and the software itself will consider the first observation of the new coding to be the next time point. If you have an external study that has reported the comparability ratio, we will write the comparability ratio and its variance here from that external study. However, it is important to note that if one uses the homostatic error option for joint point in the input file, then the variance of the comparability ratio will be set to NA, not applicable. And it cannot be changed. So if we want to insert the variance of the comparability ratio, you would need to change the option of the homostaticity. In order to use the jump model, we will come to advanced analysis tools and untick comparability ratio and instead click on jump model, where we will choose the last observation of the old coding system. If we want to see the standard joint point analysis, which is the joint point analysis without considering the jump model, we will also click on this option. Then we will push execute. Here in the results or in the output window, you can see that the joint point regression was performed twice, once with the traditional joint point regression and once with the jump model. For instance, here in the covariate value of total, the best jump model is with one joint point, and the best traditional joint point was also the model with one joint point. And to see if the jump was statistically significant, we can come to jump model tab here and see the probability of the jump. For instance, the p-value was 0.1, so the jump was not statistically significant. And here you can see the comparability ratio calculated by the system.